Hi guys, in this video I want to talk about function composition in Haskell. Not just simple composition using dot operator, and more about more complex composition. Okay, all we know that Haskell has function composition. For example, I can compose two functions like +1 and times 2. Okay, and I've got a new function, as we can see. Okay, and it works just as expected. It multiple 1 by 2 and then adds 3. Okay, adds 1, sorry. This is okay, but what if we have more functions and I want to compose ways somehow complex way? Okay, let me show what I mean. For example, I have first function will be f1, and it takes some numeric argument, and all it's just add 1 to it. And the second function is function f2, which takes some string and add exclamation mark to it, to the end of it. And the next function is take list and add element to this list. Okay, and I have function g, which take a, b, c and makes a tuple a, b, c. For example, g may be some more complicated function. Okay, but what I want to do next, I want to compose these four functions, f1, f2, f3 and g, and compose in this way that g takes a, but I want to transform this a with f1 before it goes to g, and also I want to transform b with f2 and c with f3. How can I do it? I can do it in the simplest way. I can just write new function c free, and okay, I call it c for simplicity, and it takes g, it takes f1, f2, f3, and also it take arguments x1, x2 and x3, and all it do, it takes g and send new arguments to it, f1 x1, f2 x2, f3 x3. Okay, and now I can make a new function. If I partially apply to see some arguments, g, f1, f2, f3, and I call this new function p, and I can now call it if I supply arguments. Okay, first argument will be 1, second argument will be string high, and empty list third argument. I call it, and I got correct result of which working as my composition function. constructed from these four functions. Okay, but can I somehow do it in other way? Here I need to write this C function, and it's not general. It's written for this case, but of course it can be used for different functions, not just g, f1, f2, f3. It's general in this way, but if I want to compose more functions, it's not general. And how can I generalize it? I think I want to look at some examples, and one of them will be nested lambdas. Okay, I can create new lambda which takes some argument, for example a, and okay, it will be a lambda which takes three arguments, a, b, and c. And now what happened inside of this? Inside of this lambda, sorry, I need to look at my notes. A little bit. Okay, we've got one lambda. I want to implement it using nested lambdas. and we got first lambda which take a, and then it returns new lambda which takes b, and this lambda also returns new lambda which takes c. Okay, I'm nesting my lambdas, and now in the end I have all three these arguments for my new composable function. And I can take this last lambda and compose it with f3. Okay, and take next lambda and compose it with f2, and take last lambda, outermost lambda, and compose it with f1. And what I should have here? Here, of course, I should have g with a, b, and c. Okay, and this is my new composed function. And let's generalize this with g again, and we've got such a thing. Okay, and this should work. No, this not works. Sorry, I don't need these braces. I need to just say this function this some name, and I call it z, and look at the types of z. Okay, the types are, as expected, determined by functions f1, f2, and f3, the final type. Okay, we can generalize this more if we take this lambda in this way. If we add more arguments, f3, f1, f2, and f3. Okay, and now look at types. Okay. Yes. That composition as we want in type signature. Okay. We have some intermediate functions which change our arguments and then pass them to the final function. Okay. I'm a little bit confused why here is A2, A1, A. This is strange. I've got okay, this is okay. I've got this function with t, and all t's are getted from these functions with change a's. This is correct composition, and I can see it with some call. No, not correct. Not correct. Okay, some problems. Sorry. I've got this is function for composition, and I need to provide functions to call it before call it. Okay, so z, f1, f2, and f3. Okay, and save, also save, and call this zz. And now I can run it. Yes, it works as I expected. So I have new function z, which can compose some other functions in this way. Okay, this was one way of doing this, but it also implies me to write that new function which do the composition. Okay, but let's look at the other ways of doing it. Other ways of doing it. I want to sleep today, sorry. ABC. There is one more way of doing these things. Sorry, I'm looking at my notes. There is one more way of doing this thing. If I have okay, let's look at our building blocks, at our elements. Our elements is G, F1, F2 and F3. Okay, what if I don't want to write this function, composable function, and give to it name? I just want to run this thing in some one place. When I can get G, compose it with F1, and what I get, and what I've got, I've got function from T2 to something. And this okay. What I do now, I just apply to it first argument. Okay, I do application, and I got function with less arguments. And now what I can do, I can compose it with F2. Okay, and apply some argument to it. For example, empty string. And what I got, I've got some problem. Two. Sorry, I need braces. I think I need more braces. Yes, так. And all I got function with one argument, and I can compose it with F3, of course. And now I can call it with F3. And what I've got corrected result as I expected. And I do this composition for my case, and I not write something more. I have just these blocks, and in one line I do the composition, but I my arguments are fixed. Of course, I can generalize this thing with new lambda. A, B, C. A, B, C. Two. And I must change only arguments, okay? And this should work. And of course I need a name for it. I will call it V. I have some error. I don't know. Okay. Yes. And of course I can call it 1, 2 and empty list. Okay. But again, I wrote this composition in one more line. Okay. What I want to say in the now what I need and why I review all these ways of doing composition. I want to do this in more algebraic way. If I have function g, and then, for example, I have somehow some algebraic operators, some fantastic, I don't know, called something like this, for example, and I want written this, and I want to, for example, to get what I expected, but I don't found way of doing this in general. I found only this way of doing this for certain types of then I apply my arguments when I must apply my arguments in this way. Where is it? In this way, I mean. Okay, I do it so, but arguments are fixed. How I can get it in a point-free style? Okay, so in this way, if I where I have all these building blocks gf1, f2, f3, I want some smart operator, algebraic operator, which takes all this and reduce that to my new composed function. How can I do this in Haskell, guys? Do you hear me? Can you give me a correct answer? I don't know. I think I need to do some algebraic type which generalize the notion of function, embed the function in it, and div type class defines some operation on these types which compose them, and I think it should be monoidal instance or something like that. Okay, if you know how to do this, please let me know. It's very interesting to me. Thanks for watching.